Let's review the area of a regular right triangle. If you recall from our last session, we determined that if we multiplied side 1 times side 2 and divided by half, we get the area of a triangle, because it's exactly half that of the square. So let's say that the side is 4 and this side is 4. We get 4 times 4 divided in half, or 16 divided by 2 equals 8. So this triangle is equal to 8 in its area, and the area of this triangle is also equal to 8. Here we have that same square again, and if we take 4 times 4, we get the area of the square, which is 16. But what if it's a rectangle? How do we determine the area of a rectangle? Well, one way we could figure this out is we could take this extra piece and turn it into 2 squares. So let's do that. Let's put a little line here to divide it in half. And this ends up being 2 by 2 and 2 by 2 again. Or 16 times 4, or I'm sorry, 16 plus 4 plus 4 more. Each one of these is worth 4, this is worth 4, and this is worth 16, which comes out to 24. But if you notice, here we have 4 and 2. 4 and 2 is 6, and 6 times 4 is also 24. So we can just multiply the length times the width to get the area of the rectangle. 4 times 6 is 24. So this side times this side, just like we would for a square, it works exactly the same way. So we know that the area of a regular right triangle is side 1 times side 2 divided by 2, or half of side 1 and side 2. And the area of a rectangle is the length times the width. So this side times this side. So now it's your turn. What is the area of this right triangle? What is the area of this rectangle? And then how many of these triangles will fit inside the rectangle? In other words, if this area, how many times can it fit into here? Go ahead and pause for a moment and figure out this question for me. Okay, I hope you're back. Let's see what we found out. So we have 6 times 6. To find out the area here, we need to multiply those together and divide by 2. So 6 times 6 is 36 divided by 2. Gives us the answer of 18. So the area of this green part here is 18. And then to find the area of the rectangle, we need to go 6 times 18, coincidentally. 6 times 18 is 108. So how are we going to figure out how many of these fit in there? Well, we can divide this, the area of the rectangle, by the area of the triangle to find out how many of these will fit inside there. And so if we want to find out the number of triangles that will fit in, 108 divided by 18, and that gives us 6. So we should be able to figure out to fit 6 of these triangles inside this rectangle. Well, let's see what happens. Okay, there we have 1, 2, 3, 4, 5, and indeed we can fit 1, 2, 3, 4, 5, 6 of them inside. Next up, so parallelograms. Parallelograms are similar to rectangles, except they're sort of tipped to their side. They're slanted a little bit. So how do we figure out this parallelogram? First of all, we have to draw what's called an altitude. An altitude is a perpendicular line to the base. So here we have the base. Here we have a line that's going straight up and measuring the height of this. How tall is it? So we need to know how tall it is. So we draw this thing called an altitude. The altitude tells us how tall. And in this case, the altitude for this parallelogram is 5 and the base is 12. You can see when we draw this, it creates a little triangle here, right there. So let's take this triangle and we're going to move it over to the other side. Let's move that over to the other side. And you can see now that the this turns it into a square. I mean, a rectangle. So here we have a rectangle that is 5 by 12, and we already know how to do that. So all we have to do is multiply the base times the height, which in this case is the altitude, and we get 5 times 12 is 60. So that parallelogram that we had, that is equal to 60. What if the triangle is not a regular right triangle? What if it's another shape? So what we do is, once again, similar to that parallelogram, we are going to draw that altitude in. Notice that altitude is a right angle. So right here we have a total base of 6. And then on this side it's 5. And on this side it's 1. And our altitude is 4. Well, if we take both of these little pieces, we can actually create a rectangle out of this whole thing. So if we did the whole rectangle, we would have 6 by 4. But we only want these little pieces. So we have 4 times 1 is 4 divided by 2 to get just this amount. So we know that half of a square works that way. So half of a rectangle, we can see it's exactly half. And then here we have half over here. So this is half of this. So 4 times 5 divided by 2. Well, I can see that I have a 4 here and a 4 here. So I can actually take that out of the equation. And I can have 4 times 1 plus 5 divided by 2. So here's our 1 and our 5 and our 4. And we know 1 plus 5 is 6. So really what we're doing is we're doing the base times the height, that altitude, and dividing it by 2. So we get 4 times 6, and the answer is 12 for our triangle. So very similar to the way we did a regular right triangle, but instead of taking the two sides, we now take the base and the altitude, or the height. So the equation for a triangle is to take the base times the height, the altitude, and divide it by 2. Well, what happens to the altitude when a triangle is obtuse? Because, wait a minute, we can't, it won't fit in here anymore. We need to go from the highest point. So let's draw our altitude. It ends up being on the outside of the triangle itself. So if we have an obtuse triangle, a triangle whose angle here is greater than 90 degrees, it sort of slants away, this altitude is actually going to be drawn outside of the triangle. But this will not affect the way we calculate it. So here we have our base is 8, our altitude is 5, or our height, and so our base times our height is 8 times 5, half of that, and we get 20 for this. So can we show that? We sure can. So what we can do is we can take this and rotate. We're going to make another copy and rotate it around and combine it together. Now we've doubled this area. So we've created a parallelogram. We know how to do that. We just find the base times the height. So the area of the parallelogram is going to be base times height, and the area of the triangle is going to be 1/2 of that base times height. Pause again and see if you can figure out the answers if the base is 13 and the height is 6. All right, let's see how you did. So with the base 13 and height 6, to find the area of the parallelogram, we're just going to multiply those two together, 13 times 6, and we're going to get 78. And then half of 78 to find the area of the triangle, and the area of the triangle is half of that, which is 39.